We can get started now. Okay, coming to the distributed processing. So like in typically like if you have seen any transactions which are working parallelly, if any process been working in a distributed manner, like so in such a situation we'll go for this is one of the key component or key processing in the cloud computing. If you have like a large amount of data to be processed in a distributed environment, in a distributed approachable manner, right? So in that case what happens, like you have one single compute resource. If it is taken maximum load on it, what it does, like it will send that particular request to the another server, or which is uh, you can say even distributed processing or the parallel processing, or that way that particular server cannot take more loads than whatever it's coming on its way. So it will distribute that request, the processing request to the another servers which are available. That's where that particular server can minimize load on it, and the number of requests which are processing at the same time can be processed at the same time, I mean without any disruption, or taking more time to complete the transaction. Okay. And coming to the disposable resources. So when you see in the typical IT infrastructure environment, in the cloud computing way, you'll have the environments after some a particular some time, you need to dispose it and go for the new infrastructure, and there will be some money also, it will get wasted, the resources. But when it comes to the cloud computing, all infrastructure is temporary or disposable. You can do it very easily without even looking for what is like lose, I mean what you're going to lose if you are disposing that particular server or whatever, right? So the new instances can be launched whenever you wanted to have, whenever you have the new requirement, right? So that's the beauty of the cloud computing. That's one of the key feature that most of the uh, uh, things which will happen in the cloud. At any time you can have a new environment ready, and you can create the new instances based on the requirement. Coming to the next slide, which is automate compute resource initiation, which is one of the like AWS feature, you can say. And whenever you wanted to make a new environment, or automate, or we can have the similar repeatable process multiple times, right? That you can have, you can, I mean, configure that in the AWS using the bootstrapping and hybrid approach that you can follow. Coming to the bootstrapping, so there is a you can launch AWS resources with the default configuration and execute automated scripts to install in software and copy data to bring those resources to the required state. What it means is, like, you can have the default configuration and you can execute the automated scripts in an automated way. There is no manual process here also. You can install the software and copy the data to bring those resources to the required state. This is not only for one system. If you wanted to do this for the multiple system, the bootstrapping is the feature that is given in the AWS. Let's say I have organization where I have I have to give a similar set of system for all the employees, that instance, right? If you do it manually, that takes a lot of time, right? So you should not be doing that manually, the same instance creation and providing it to your end users. So the bootstrapping will do all these things in an executed fashion, automated fashion. I'm sorry, automated fashion using the bootstrapping mechanism to have the data and create all your instances and copy the data and make your resource available for all your services. And this is where your chef and puppet, these are like a work ops work life cycle events, or cloud formation. All these we can achieve the bootstrapping using these tools. uh, Mostly the chef and puppet will be used most of the people in the infrastructure team, what I see in my experience, to create the clone of the system. You're doing all, I mean, bootstrapping is nothing but cloning the similar kind of environment for multiple more than the required systems. That's the bootstrapping. Okay, so coming to the golden images, what golden images stand here is like if you have to take some snapshot of EC2 instances and RDS instances or EBS volumes which can be launched in a new instances. And all these EC2 instances can be customized and saved to Amazon, like AMIS, which is Amazon Machine Images. All the images will be stored in a periodical way, and whenever you wanted to see the state of the EC2 instances or RDS instance or EBS volume, how much volume was particular server has used it, and what is availability of the volume in that particular server. So all that images can be stored periodically, and whenever you wanted to the previous state and see those information, all that information will be available for you in these services which is provided by the Amazon.
Can I ask a question?
Yes, Patrick.
Yeah, with the bootstrapping and this golden image, do you have to write any codes for it to have those
No,
uh,
no,
data
no.
transfer? Okay,
No code is required. All these are services which needs to be enabled as per the, I mean, like based on the requirement that you have it. All everything is automated. Everything is configured. You need to enable the configuration to avail this feature in your application.
thank you.
Okay. Yep. No, you're welcome. And coming to the hybrid approach, so probably you might have heard a hybrid cloud. So it's also similar to what a hybrid cloud talks about here in the approach. If you see, like utilizing both bootstrapping and golden images to automate your compute launch process. So we would be using both the features what we discussed so far, like a hybrid approach and also bootstrapping. If you are using both the things together, it's called a hybrid approach for your new instances which you wanted to launch. So that's pretty much clear, straightforward case. And the next slide is infrastructure as a code, and AWS assets are programmable. So you can even do some kind of a coding, but not in all the services. But you need to know like which are the services that can be like programmable in order to achieve what you want, what you are intended to do with those services. Like we can apply like any techniques discussed earlier to entire environments and not just individual source. Like using the cloud front, we can do this, like coding, infrastructure coding. So, which is like we'll discuss about the features of it, I think, in the later slides. And coming to the automation services, which is given by the AWS. So the Elastic Beanstalk, EC2 auto recoveries and auto scaling, CloudWatch alarms and events, and OpsWork lifecycle events. So a couple of things here in the services we have been already discussed in the earlier slide, but we'll I mean, cover it up at high level to understand what these services does. So Elastic Beanstalk, which will take your I mean, a request, and all these beanstacks will be taking your request and understand how this request can be processed, and these services will be in a position to take that particular request and how it can be parallelly processed. That beanstalk will be taking care into those requests. And auto recovery, elastic EC2 auto recovery will be let's say if you're as we discussed earlier, like if there is any failures happens and if the data is lost, and EC2 auto recovery knows how to take the backup from the existing replicas of that particular instance which has been already been configured, and it takes care of auto recovery. And auto scaling, like as we discussed, scale up and scale down depends on the workload which is being put on the server. Based on the incoming requests which are coming to the system, the auto scaling will work out. Okay. And CloudWatch alarms and events, we discussed about it. Like if you have a couple of events and how the particular server is behaving, all this CloudWatch and alarms and events will take all that request, and it knows how to pop out that events, and also give the alarms if there is any disasters which are foreseeing in the server. And ops work lifecycle events, which we have seen in the earlier slide. Like there are 5 diagram which says like what are the different aspects that we need to take care as part of the operations work lifestyle events. So that will be covered in the ops work lifecycle. This everything you can say is automation services using the AWS. So this is one of the service. And coming to the loose coupling. So loose coupling in the normal cloud computing field, what you see is if you have any different components work together, and if there is any one single failure happens, you can replace that service with another service, but the existing flow will not have any kind of effect. If you see in this diagram, like uh, okay, so here this is a storage, and here you are doing some kind of transaction or the processing here. It goes to your servers, I mean your applications, and go to the server. There is a one failure happened with one web service, like maybe some failure happened the web service, but still the request will go to the another web server, and it takes care of till end to store that particular transaction to the storage. So it's very much loosely coupled. It's not tightly coupled, and there is no much dependency on this particular process that we do in AWS. So this is very much, great feature which is given by the AWS. And well-defined interfaces. And when it comes to the interfaces or the components which we would be using in our transaction, like you can use through RESTful APIs. So I'm not sure like if you are aware of like RESTful APIs, where we make a web service call from different resources to another resources. AWS is one of the Amazon Web Services. It's like we would be using RESTful APIs in a manner to get the informations from different resources using the API gateway. And all these transactions and the data which is being moving from one server to another server will be very much secured by having all the cloud uh, features enabled to it. Okay. Okay, coming to the service discovery. When we have seen that loose coupling, right, ensuring that services interact with each other without any prior knowledge or their existence. So it will come to understand when the service got interrupted, the load balancer is the one which will route your request to the another server. So that's where the service discovery has come into picture with the load balancing concept, which is like elastic load balancing concept. In the previous slide which we have seen, right, when there is one request which got failed, elastic balance is the one which will know there is another web server to route that request to another server without any disruption. So that's where this service discovery will come into picture to take the request without any failures. And coming to the asynchronous integration. So like in the intermediate storage layer, what we do here is like in the all the requests will be stored in a SQSQ. So when it stores in the SQSQ, it doesn't know like from which server or the resource that particular request is coming in. For example, if the resource A is sending a request to imagine SQSQ, so here the request will be stored here, and it sends the notifications to SQS. And all this decoupling, we call it as decoupling. So all the computers here, so you'll call it as a resource A, B, C, all your compute resources, and like it's not directly linked to each other. It is linked through this image and SQS. All request will be queued into this SQS, Amazon SQS. So it knows that let's say if you have 10 requests which are pending in Amazon SQS, it knows like to which resource the request has to be sent based on the availability of the resource. It doesn't, the resource A will not have direct connection with the resource B. It will route it through SQS, which we have uh, kept it as under the configuration. So this is how the asynchronous integration will work here. Okay. And one more feature what we see here is a graceful failure. When you have applications which are designed fail gracefully, if you design any application which is a fail gracefully, like say this is your primary website and this is your backup website, but as a resource you are trying to access your primary website. But what S3 like a route 53 does is, if your primary website is not available, it route it through to your website backup website, not to the primary website. This is the one of the graceful failover, and it knows how to route it based on the configuration that this particular service is built on. Like without any I think I'm clear on this service. Other resources will continue service without